Today's video starts on page 13 in your packets. It's a problem of the day. I'm going to leave this for you to do on your own. I'm going to do a couple of the homework questions on the next couple pages just so that we don't have so much to do in class. The first one I'm going to do is number 2 here. The big screamer coaster carries 92 people all together. Some of its cars carry 4 passengers and the rest of the cars carry 6 passengers. There are 3 less 6-passenger cars than 4-passenger cars. How many 4-passenger cars are there? So I'm going to say let X equal the 4-passenger cars. And since there are 4 people in them, I'm going to multiply that X times 4. So I'm going to put that in parentheses afterwards. You'll see in just a minute. The big screamer coaster carries 92 people. That's my equation. My 2 kinds of cars are going to add together to equal 92. So some of its cars carry 4 and some carry 6. Okay, I'm going to put that in the let statements. There are 3 less 6-passenger cars than the 4-passenger cars, which I called X. 3 less 6-passenger cars than X. So 3 less X. Okay, so let X minus 3 equal the 6-passenger cars. And I'm going to multiply that quantity by 6 because 6 people go in those. Okay, so when I add my 4 passengers times X plus my 6-passenger cars, which are X minus 3, there are 3 less of them, all together I get 92 people. So 4X plus, and I'm going to have to distribute first, 6X. So I have 4X plus 6X, which I know is going to give me 10X. And 6 times that negative 3 is negative 18. So I have 10X. Negative 18 equals 92. 10x minus 18 equals 92. So I'm going to add 18 on both sides and balance this equation. And I get 10x has to equal 110. Well, isn't that nice? When I divide by 10 on both sides and get those to cancel, I get that the 4-passenger cars, there are 11 of them. And the 6-passenger cars, there are 8 of them. So if there's 4 passengers in the 4-passenger cars and there's 11 of them, 11 times 4 would give me 44. And there are 8 cars that have 6 passengers in them, that's 48. If I add 44 and 48 together, do I get 92? Yippee, there's my check. So how many 4-passenger cars are there? Doesn't ask me how many 6-passenger cars, so I'm only going to say there are 11 4-passenger cars. And I put that 4 in parentheses, or I could have put a slash here because I didn't want it to look like 114. There are 11 of those 4-passenger cars. Sentence answer box label. Let's go on to the next page. I'd like to do question number 8. Find 3 consecutive, in order, in a row, like A, B, C are consecutive letters. 27, 28, 29 are consecutive whole numbers. -3, -2, -1 are consecutive integers. But this says find 3 consecutive odd integers such that the sum of the smallest and 4 times the largest is 61. Find 3 consecutive odd integers. Consecutive integer means it cannot be 6 1/2 or 75 hundredths. It's got to be a whole signed number. So that's going to tell me how to set up my let statements. This first part of the phrase, find 3 consecutive odd integers. Okay, so I'm going to say let x equal the first, and I'm going to say cons for consecutive, odd, and int for integer. Odd numbers are 2 apart from each other. So say I get the odd number 13. To get to the next biggest odd number, 13 plus 2 would give me 15. So if odd numbers are also 2 apart, so the second consecutive odd integer must be my x, whatever I figure it out. If I add 2, then I'll get to the next odd number. So x plus 2 is the second consecutive, abbreviated, odd integer. And then the third one, so say the number is 13. If I add 2, I'm going to get 15. But if I add 4 to 13, I'll get 17, the third. So I have to keep adding 2 more. So it's like x plus 2 or x plus 4 equals the third consecutive odd integer. Okay, so 3 consecutive odd integers, 3 let statements. I'm going to have to find 3 numbers in a row that are odd, that are consecutive in a row, such that the sum of the smallest, okay, the smallest one would be the x. So x and 4 times the largest, it's a sum, x, the smallest, which I know is x, and 4 times the largest, which I'm calling x plus 4. So that's going to have to go in parentheses, 4 times that x plus 4. So this is a distributive like terms problem. So the sum of the smallest x and 4 plus 4 times the quantity x plus 4 is, that's the equal sign, 61. So I'm going to distribute first, and I get 4x, and 4 times 4 is 16, and x plus 4x gives me 5x. There's my like terms. It does equal 61, so I have x plus 4x, that's 5x, plus 16 equals 61. I'm going to subtract 61 on both sides, and I get 5x, those cancel, equals 45. And when I divide by 5, I get x equals 9. Well, I have 3 let statements here, so I have to answer all of them. X equals 9. Well, 9 plus 2 more, that equals 11. We're looking good so far. 9 and 11 are odd numbers, and they're in an order, right? They're next to each other. They're consecutive. And 9, x plus 4, 9 plus 4 would give me 13. Okay, so I think the numbers are 9, 11, and 13, such that the sum of the smallest, okay, here's my check, 11, added to 4 times the largest, well, 52 plus 11, yes, that equals 63. Yippee! The consecutive, can't abbreviate here. You can abbreviate in your let statements, not in your Sable. Odd integers are 9, 11, and 13. Full sentence. And if this is not enough space for you, please take out a piece of paper or work in your spiral and copy these into your spiral. Even better. You got all that paper in there. Because this is not a lot of space for those of you that write kind of big. I'm going to go back up and I'm going to do number 6. Find 3 consecutive integers. Oh, they're not odd. And it doesn't say even like number 7 does. Because even numbers are also 2 apart, right? 2, 4, 6, 8, there's 2 apart. But consecutive integers whose sum is negative 147. 3 consecutive integers. 3 again. So they're in order. So this time, let x equal the first consecutive, I don't have to say odd or even, integer. And then x plus one more, the very next number is one bigger, be the second consecutive integer. And let x plus 2, now I'm only adding one more every time to get the third consecutive integer. Find three consecutive integers. That's my let statements. Now, whose sum is negative 147? Ooh, these are going to be negative numbers. So I'm going to add these let statements together. First plus second plus third. Their sum, first number plus second number plus third number, is negative 147. Lots of like terms. X plus x plus x, 3x. 1 plus 2 is 3. So 3x plus 3 has to equal negative 147. Subtracting 3, same signs, add and keep. I'm going to get 3x equals negative 150. When I divide by 3, I get x equals negative 50. And if I add 1 to it, adding 1 to it, negative 50 plus 1, it's not negative 51, it's negative 49, right? Different sign, subtract. Negative 50 plus 1, I'm going to subtract. And add 2 to x equals negative 50. Negative 50 plus 2 is going to give me negative 48. Now, is the sum of negative 50, negative 49, and negative 48 equal to negative 147? I bet it is. But here I'm checking. 9 and 8 is 17, carry the 1, 6, 10, oh, yep, same signs, add and keep. Negative 147, I checked. Here's my little mini check. Find three consecutive integers. The consecutive integers are negative 50, negative 49, and negative 48. So we've done consecutive integers and consecutive odd. Consecutive even, number 7, works just like consecutive odd. Same three let statements, x, x plus 2, and x plus 4. Consecutive integers are always x, x plus 1, x plus 2. If you've got to find 4 of them, x plus 3. If you only have to find 2, then it's just x and x plus 1. But they set up consecutive integer problems, and you can see we have a whole bunch of them on this page, set up the let statements exactly the same way. You just got to pay attention to even and odd. And that's it for today's video.